Welcome to the Deep Dive. We're your source for, cutting through the noise and getting to the heart of complex issues. Today, we're tackling something everyone faces: making tough decisions when you just don't know what the future holds, especially in business. How do you choose the best path when you can't be absolutely sure what's going to happen? We use forecasts, sure, but they're never perfect, are they?
Exactly. And that's what this deep dive is all about. We're going to look at how you can systematically think through all the possibilities, all the potential outcomes, and importantly, their chances of happening. It's about evaluating risk, especially when you have some past data, some statistical evidence to lean on.
Right. We'll unpack some key tools for this: expected values, decision trees, and combined probabilities. These sound a bit technical maybe, but trust us, they are incredibly powerful for real-world strategy. Okay, let's dig into these tools then. First up, expected values. What are we talking about here? Simply put, it's like a way to get a single number summary for a decision with uncertain outcomes. You weigh each possible result by how likely it is its probability and add them up.
It gives you the average result you'd expect if you could repeat that same decision many, many times. It's an average over the long run.
Not necessarily what happens this time, but the average.
Okay, precisely. And that leads nicely into decision trees.
Yeah.
Think of these as, diagrams, maps almost. They help you visually lay out the sequence of choices and uncertain events. You see the different paths opening up.
On a flow chart for decisions.
Sort of, yeah. And expected values, they're often used right there on the tree to figure out the value of each branch, each possible path.
Got it. And then there's combined probabilities. This is where it gets really interesting, I think. For instance, say event 1 has maybe a 60% chance, a 0.6 probability. And event 2 only happens if event 1 happens first, and then it has a 75% chance, or 0.75.
Right. Dependent events.
So the chance of both happening in sequence isn't just adding them up, you multiply them. 0.6 times 0.75, that's 0.45. Only a 45% chance of that whole sequence playing out.
Understanding that multiplication is crucial. It tells you the true likelihood of getting down a specific path on that decision tree.
Okay, theory is good, but let's make it real. We're diving into a scenario. Brisport master Motoco. They design and sell car components. Their teams come up with something new for hybrids, drastically improves battery road time, less recharging needed. Sounds great.
Sounds like a winner, potentially.
But now they have a big decision. Option A, sell the design right now, get $400,000 for it, walk away.
Clean break.
Or, option B, try to develop it into a marketable product themselves. But that costs $300,000 up front, and it's going to take a whole year.
And development isn't guaranteed, of course. There's uncertainty. They estimate an 80% chance of success.
Okay, 80% is pretty good.
But there's a 20% chance it fails. And if it fails, they can only sell the original design for half its value, $200,000, and that's a year from now, remember?
Right, so time value of money comes into play too.
Yeah.
Now, what if development succeeds? That 80% chance path. Then they face another decision. Decision 2.
Correct. A fork in the road after success.
Option A, post-development. Sell everything, the design and the rights to sell the product. That brings in $300,000 in year 1, plus $160,000 a year in royalties for 5 years after that, years 2 to 6.
Okay, predictable income stream there.
Or option B, post-development. Market the component themselves. Go it alone. This is riskier.
How so?
Well, they figure there's a 75% chance it's popular. If so, great. Cash inflows of $440,000 a year for those 5 years.
Big upside.
But there's a 25% chance it's unpopular. And if that happens, it actually costs them money. Cash outflows of $55,000 per year for 5 years.
Ouch. Wow, yeah. A significant downside risk there, too. And we need to factor in their cost of capital, right? They use a 7% weighted average cost of capital to discount these future cash flows. So all those future dollars, the royalties, the inflows, the outflows, they all need to be brought back to today's value, net present value or NPV.
Exactly. We need to compare everything on a level playing field in today's terms. So Brisport's dilemma. What should they actually do?
Well, with a decision tree, the standard approach is to work backward from the end. So we tackle that second decision first.
The one they face if development succeeds, marketing it themselves versus selling the rights.
That's the one, because the answer to that tells us the value of the development succeeds branch on the first decision tree.
Okay, let's break down that marketing option then. 75% chance it's popular.
If it's popular, the NPV after discounting all those $440,000 inflows at 7% comes out to a positive $1,386,000.
Nice, but the unpopular scenario. 25% chance.
If it's unpopular, discounting those $55,000 outflows gives a negative NPV, a loss of $511,000 in today's terms.
Right. So To get the expected NPV for choosing to market, we do that weighted average thing again.
Exactly.
So 0.75 times the $1,386,000 gain plus 0.25 times the $511,000 loss.
And the numbers.
Okay, 0.75 by $1,386,000 is $1,039,500. Let's call it $1,040,000. And 0.25x $511 is about negative $128,000. So $1,040,000 minus $128,000 gives an expected value of $912,000 for marketing.
$912,000. Now, compare that to the alternative at that stage, selling the design and rights.
That NPV was, let me check, based on expected value anyway.
If development succeeds, they should plan to market it themselves because $912,000 is much better than $594,000.
Correct. So we've resolved decision 2. The expected value of the development succeeds path is now $912,000. We plug that back into the first decision.
Right, the initial choice. Develop versus sell now.
So the develop option has 2 main branches now. An 80% chance of success, leading to that expected outcome worth $912,000 in NPV.
And the 20% chance of failure, what's the value there again? Failure means they sell the design for $200,000 in 1 year. You discount that back at 7%, and remember, you have to subtract the $300,000 development cost paid now.
Ah, right, the initial cost.
When you calculate that NPV, it turns out they're actually worse off by $113,000 in present value terms if development fails.
A negative $113,000 NPV for the failure branch. How'd you get?
So now we calculate the overall expected NPV for the entire development option, decision 1.
Okay, so that's 80% chance of the $912,000 success value.
Which is $729,600, call it $730,000.
Plus the 20% chance of the $113,000 loss.
Which is $913,000, call it $923,000.
So $730,000 minus $23,000 gives a total expected NPV of $707,000 for trying to develop.
$707,000, that's the expected value of taking option B, the development path.
And option A was just sell the design now for $400,000.
Correct.
So comparing $707,000 expected value from developing and marketing versus $400,000 from selling now.
On a purely expected value basis, the decision seems clear.
Develop and market. $707,000 beats $400,000.
That's what the numbers say. But, and this is a big but, expected value assumes something called risk neutrality.
Meaning the decision maker only cares about the average outcome, not the potential upsides or downsides specifically.
Pretty much. They're indifferent to the spread of outcomes as long as the average looks good. But is Brisport's management really risk neutral?
Probably not entirely. I mean, look at that failure scenario. A 20% chance of ending up $113,000 worse off than doing nothing? That's a real risk that might make a board quite nervous.
It certainly might, and there's more risk buried in there, even if they succeed with development and choose to market.
Right, there was still that 25% chance of it being unpopular.
Leading to that big $511,000 loss in NPV terms. So we need to think about the overall probability of ending up in each final state. This is where combined probabilities come back in.
Okay, so the chance of the best outcome development succeeds and it's popular. That's the 80% success chance times the 75% popularity chance.
0.80 times 0.75.
Which is 0.60. Or 60%.
Yep.
So a 60% chance of that $1,386,000 positive NPV.
Good. Now, what about the outcome where development succeeds, but the product is unpopular?
That's the 80% success chance times the 25% unpopularity chance. 0.80 times 0.25.
Which is 0.20.
A 20% overall chance of ending up with that $511,000 loss.
And the last outcome.
Development fails outright. That was just a straight 20% chance leading to the $113,000 loss.
Perfect. So let's summarize those actual possible end states for the development path. Outcome 1, success and popular. 60% chance plus $1,386,000 NPV. Outcome 3, development fails. 20% chance, netted to $113,000 NPV.
Okay, seeing it laid out like that, it hits differently than just the $707,000 expected value. That average number hides a lot.
It really does, because this Brisport project, it's a one-off decision. They don't get to run this experiment hundreds of times to average out the results.
Like flipping a coin once, you get heads or tails, not half heads, half tails.
Exactly. They will end up in one of those 3 states. And look at the probabilities.
Yeah, add up the chances of the negative outcomes. 20% plus 20%. There's a 40% chance the actual NPV result will be negative if they choose to develop.
A 40% chance of losing money in present value terms. Now, that might be a risk the company directors are simply not willing to take, even if the expected average looks good on paper.
It totally reframes the decision, doesn't it? It's not just about the average, it's about the potential pain points.
And it highlights another critical aspect. How reliable are those probabilities in the first place? The 80%, the 75%, where did they come from?
Good question. Often they're subjective estimates, right?
Huh.
Based on market research, gut feeling maybe.
They often are. And the whole decision can be very sensitive to small changes in those estimates.
Can we test that? Like, what if the chance of successful marketing wasn't 75%, but say, only 55%? Does that change decision 2?
Let's see. If popularity chance drops to 55%, unpopularity chance goes up to 45%. The expected NPV for marketing then becomes 0.55 by $1,386,000 plus 0.45x $511,000.
Okay, 0.55 times 1.386 million is about $762,000. And 0.45 times negative $511,000 is about managed $230,000. So $762K minus $230K gives $532,000.
$532,000. Now remember the NPV of the alternative at decision 2, selling the rights?
That was $594,000.
So if the probability of success was just 55% instead of 75%, suddenly selling the rights looks better than marketing it yourself. The optimal choice at decision 2 flips.
Wow, that's sensitivity analysis in action. It shows how much your conclusion depends on those initial guesses about probability.
It's vital. You have to test your assumptions, see how robust the decision is.
Which brings us back to the idea that these models, these tools, are only as good as the information you feed into them.
Absolutely. And real-world problems often have way more potential outcomes than just 2 or 3 neat possibilities, like in our example. It's usually more of a continuous range.
True. Life is messier.
But even with those limitations, these techniques, expected values, decision trees, thinking about combined probabilities and sensitivity, they give you a powerful framework, a structured way to grapple with that complexity and uncertainty.
So wrapping this up, what's the big takeaway for you listening? We've seen these tools can really help clarify complex choices, like the one Brisport faced.
Definitely, they bring structure. But we also saw the potential pitfall of just looking at the expected value, especially for unique one-off decisions. Understanding the range of outcomes and your own tolerance for risk is key.
Yeah, and checking how sensitive your decision is to those probability estimates. Are they solid or just a guess? So think about a big decision you might be facing, maybe at work, maybe personally, where things aren't certain. Could actually mapping out the paths, even roughly estimating the chances, change how you see it.
And here's a final thought. We focused on maximizing expected value, but are there times when a project with a negative expected value might still be worth doing?
Ooh, interesting. Like when?
Maybe the potential upside, even if unlikely, is absolutely enormous, a game changer. Or perhaps the strategic cost of not even trying, of letting a competitor get there first, is even higher than the potential loss.
Right. Sometimes playing it safe is the riskiest move of all. Lots to think about there. This deep dive really shows that smart decision-making isn't just about crunching numbers. It's about understanding the assumptions, the risks, the context, and, the human element behind it all.
Well said.
We hope this gives you some useful tools and perspectives for your own deep dives into making choices when the future is uncertain. Thanks for joining us.